Question 15 offers us a quadratic sequence, and we've got to find an expression in terms of n for the nth term of this sequence. Now, a quadratic sequence involves finding the second common difference. So let's do that first. Okay, working the first line out, 9 take away 3, 6. 17 take away 9, 8. 27 take away 17, 10. And now the second common difference, well, this is 2 and this is 2. That tells us that n squared must be the quadratic element of the general term for a quadratic, which I've written here. So we know therefore that a must be equal to 1. So what we've got to do is take away the n squared element from our original sequence. I've given the values of n here above our original sequence. So when n is equal to 1, n squared is equal to 1. n is 2, 4. n is 3, 9. And n is 4, 16. I've got to take these numbers away from these numbers. And what do I get? 3 take away 1, 2. 9 take away 4, 5. 17 take away 9, 8. 27 take away 16, 11. We've got a linear sequence now because we're looking for a solution which looks like bn plus c. To find that, we need again to find the difference. And I think you can see that the difference here is 3. So b will equal 3. All we've now got to do is find out the value of c. And we do that by looking at the first term. We've got a 2 here, but if our sequence is 3n, that will give us 3. So we're 1 too high. So we've got to take away 1 from our result to generate these numbers 2, 5, 8 and 11. So the nth term is, what have we got? We've got n squared plus 3n minus 1. Does it work? Let's now try sub n is equal to 2. And this should be the result we get. We should get 9. n is equal to 2. 2 squared is 4 plus 3 times 2 is 6 minus 1. 4 and 6 is 10, and this indeed does equal 9. So I'm now happy that that is the answer.